Welcome to clickmyproject.com. Here we discuss about the error detection in magnetic logic decoding of Euclidean geometry low density parity check codes. In this project mainly focused on the error detection and correction method. Due to higher integrations, densities, technology scaling and variation in parameters, the performance failures may occur for every application. The memory application are also prone to single event offsets and transient errors which may lead to malfunctions. This paper proposed a novel error detection and correction method using EG-LDPC algorithm. This is useful as magnetic logic decoding can be implemented serially with simple hardware but requires a large decoding time. For memory application, that increases the memory access time. The method detects whether a word has error in the first iteration of magnetic logic decoding, and when there are no errors, the decoding ends without completing the reset of the iterations. Also, errors affecting more than 5 bits were detected with a probability were close to 1. The probability of undetected errors was also found to decrease the code block length increased. For a billion error patterns, only a few errors were undetected. This may be sufficient for some applications. In our error detection codes are commonly used to protect memory from so-called soft errors, which change the logic value of memory cells without damaging the circuit. As a technology scales, memory devices become large and more powerful error correction codes are. This is our system flow diagram. In our process, we give the feedback input to our browser. The feedback input passes into the shift register. The shift register generates a multi-level of input and outputs. The multi-level of output passes into the PIT encoder. The PIT encoder acts as an encoder processing. The encoding output passes into our algorithms. The algorithms will finally pass into the magnetic decoder. The magnetic decoder identifies the number of error bits, and finally we pass to the output into the correction gate. The correction gate check the input and output values. In case of the input and output are same, we pass the same output. Otherwise, we change the inverting operation to check our input and output are equal. This is our error correction and detection method concept. Now we are going to discuss about our project running process. First of all, in this process we have 4 steps. First step, check syntax. Then second step, we generate the view RTL schematic diagram. Then third step, we generate the technology schematic diagram. Then finally, we generate the simulation waveform. First, we check the check syntax. In this step, we check the syntax of our program. In case of any error and warning is there, display in console blocks. Please check. In our program have no errors. Then we go to the second step. Please click view RTL schematic. Then generate the RTL schematic diagram. Please wait. Please select add, then click create schematic. This is our overall RTL schematic diagram. Click data in enable reset our input signal. Our final output are SR out and C out. This is our overall black diagram, RTL schematics. Then third, we generate the technical schematic. Please click view technology schematic. Just add our project, then create schematic. This is our overall technology schematic diagram. Finally, we generate the simulation waveform. Please click simulation, then click simulate behavior model. Please give the input values. clock set to 0, D in 1. This means data input. Reset set to 1. Enable set to 1. Run our simulation. Please click the run of time specified on the toolbar. Then second, we change the clock signals only. This is our reset output. Then third, we change the reset value set to 0 and clock value change to 0. Again we change the clock signals. This signal SR out generate the output signal. This output generated from shift registers. We check our input and output signals are same or not. Then again we change the clock signals only randomly. Zeros and ones. Please wait after 15 clock cycles. Now we complete the 15 clock cycles. In our output does not match with our input signal. Please check shift register line. We have 15 1 signals. In our output signal, we change the output zeros. It represents the number of changed bit to 4. Then again we give the input signals on SR output to this process. Please. Now we give the input signal at previous output signals. This is our second iteration output values. This value differ from input signals. Please we go to third iteration.